Hey gang, welcome back to Inverted Pursuits Laboratory. This week we're going to be taking a look at the EggTimer Wi-Fi switch. This is a really cool little tool that EggTimer makes. It's a Wi-Fi enabled switch, so similar to the quantum altimeter we built. We can connect to it with our phone and control a lot of things. Let's go ahead and take a look at how the whole thing goes together. Alright guys, so we have the EggTimer Wi-Fi switch here. We're going to go through all the parts before we get to the build, just like we usually do. So, of course, it always gives us solder. Solder is just kind of a standard part of their kits. I have tons of this stacked up right now because I never end up using it all. It does come with a packing slip. So like, this is usually what I'm checking through when I'm checking everything. It's important to go through the entire list and make sure absolutely everything is there. This one also comes with a little note about 1S LiPo versus 3S LiPo and type of voltage it's looking for. So let's take a look at this real quick. So basically they're saying they switched it to be able to handle a 1S LiPo. So voltage regulator, they wanted to make note that, please make note that when you assemble your kit, these parts should be installed in the same, as the parts they replace. So LD17733 to 33S, marked LL3, otherwise it appears identical. Capacitors, you got a 10 microfarad. Closest to the right edge of the board, 1 microfarad tape carrier, black tape, 4.7 microfarad green tape. Note that in our testing we found that new regulator will not reliably operate from a 3S LiPo, even though the manufacturer specs said it should. If you need to use a 3S LiPo, for example, with a hot wire cutter or solenoid, please contact us for a free 3S regulator / capacitor kit. All right, so they moved it down to 1S and 2S operation. They got rid of 3S support. They will, however, send you a free 3S upgrade if you bought it specifically for that. So a couple parts have been swapped out. Not a big deal. I actually like that. It makes it easier to run with standard altimeters that run off 1 and 2S LiPos. But let's get into the parts of this build, the big parts. Ooh, the Wi-Fi chip. All right, let me grab out my tweezers. All right, so of course we have the circuit board. That's probably the most obvious. Sorry about that. And we have the Wi-Fi module. Both are referenced on the instructions. Let me get these out of the way real quick. Let's see. We have an LED. Yeah, we got 2 LEDs actually. So we have a 3mm amber or red LED, sorry, and a 3mm amber LED. It may come as clear, they said, depending on the parts available. So this one did come as a clear piece, as we can see. It's perfectly clear. All right. We have a MOSFET. It's a large packet with 3 leads. That would be this guy. So it's got the big 3 leads, so we got large pad on the left and 2 small ones on our right. For you guys, that's actually backwards. It's on your right and your left, respectively. I have a 3-pin header. I have optoscillators, ACPL 277 oscillators. There's 2 of them. I Then we come down to resistors. Oh boy, there's a lot of resistors. 103 resistors. We get a huge pack of 103s. We'll kind of organize those off to the side here. We have 222s, as we're supposed to. We have 223s. Most of these, please note, we do have extras of. We have 412s, 472 resistors here. Most of these you're going to denote by the numbers on top of them, and then we have 102s as our last set of resistors. Then I have in our paper carrier here that's but brown little capacitors. These are 0.1 microfarad capacitors, 1206 size. I then have another brown capacitor in a clear plastic carrier. Maybe one of, this is 4.7 microfarad, this green stripe on it, capacitor. This is I've got a 1 microfarad capacitor, it's black, striped. That's cool. Then this is our power regulator, voltage regulator. It is the 3.3 volt, or yeah, 3.3 voltage regulator as expected. Then I have got a bunch of resistors, not important, we just need them for the leads. It's pretty normal with the EggTimer just to need something like that for the leads. All right, so now we will get into the build. So first thing we're mounting are called the obfuscators. Man, I can't say the word and I'm not even gonna try. I'm not gonna pretend like I know how to say that really weird word. They mount here and here respectively. Let's see if I can actually get you guys in a little closer to what we're doing on the board here. All right, so they are the parts that come in this packaging. There's 2 of them. You'll need both of them. They go right next to each other. There is a little marking on the right-hand side of your guys' screen that matches up with a little dot in the corner right here on the part. So the guy will actually mount like that. So we're gonna go ahead and put solder on one of the pads. And then let's just try that one more time. All right, got one on there. Let's get in there and do the remainder. Alright. I'm gonna... Whoop. Alright, I'm gonna need to shift that real quick. It's getting kind of hard to see. Sorry, I keep bumping the camera there, guys. Got it in pretty tight. Try that one more time. Alright, let me take a quick inspection on that, and we will move on. Alright, I'm gonna bring this back on screen now, guys. I did go ahead and tack on the next board, so it's already attached. All we have to do is go in and solder each leg in place. There are instructions on here to wait 15 seconds between each leg, which I haven't been doing great about. So usually I am religious about those wait times, but apparently not today. So let me take a look at those 4, and then we'll do the next 4. Sweet, those are tacked down. I am spinning the board around a little bit just to help me get the best angle on it. So we come in here, we touch and get that. Come down here. On that one real quick. Clean my tip. Whoop. Completely smack the camera around. All right. Take a look at that. Those should be done. Those are in fact completed. So the next thing we're actually doing is the voltage regulator. So I'm gonna move you guys up a little bit. The goal of getting a little more space. This is kind of easier to see. All right, so the voltage regulator is the guy marked LL33. Comes like this. Has 4 pins, goes right there. So let's get it open real quick and go ahead. All right, we're gonna go ahead and drop a bit of solder on the big pad here. Your guys' left. So I want a good chunk of solder on there before I go in with the voltage regulator. So this guy comes in here. This will usually be the hardest pad to get to stick because it is so large. you usually end up needing to turn your temperature up some, or just be like me and chuck your piece off. So my goal is just to get solder to flow over the top of it, which I just got to happen, and we can let her go. So now we'll come in here real quick and solder down the remaining pads. Quick little taps, and they're all done. Next, we'll be mounting the 222 resistor right above that here. Now, the 222 should be completely legible for you guys from left to right. So let me get the 222 real quick out, and we'll get that bad boy going. All right, so we'll solder the pad here, and we will come in with our resistor. And just like that, it is tacked down. So next we will come in and we're going to get this other side. So we just want to add a little bit of solder until it takes, just like that. All right, now we're mounting the 10 microfarad capacitors. There are 2 of them. They actually get replaced. These are 2 of the ones they said changed. So we're actually going to be using the green and black capacitors. So closest to the right edge of the board is this guy here, and it gets replaced with the black stripe. So that is actually our 1 microfarad capacitor. So that's what we're mounting next, is the 1 microfarad capacitor here, followed by the 4.7 microfarad capacitor here right next to our voltage regulator. So let's go ahead and get these open real quick, and then we'll mount them. There is unfortunately a little bit of decoding to do with the fact that they changed the way these go together. So we'll quickly solder that on there. And again, this is our 1 microfarad capacitor. That's not the greatest hold, but it's enough for me to solder the other side, and I'll go back and fix that side. There we go. All right, there we go. So that is the black stripe 1 microfarad capacitor. Next, we are mounting the green stripe 4.7 microfarad capacitor. And it again is the one that mounts next to the regulator here. So alright, green stripe comes out. Definitely not the easiest way I could have done this. I have to swap hands. All right, so 1/2 the 4.7 microfarad. Here's the other half. Let's do a quick touch up on the other side. There we go. And our 4.7 is mounted. Note that those were the 2 of the replacement parts from the 3S to 1S capability change. We're now going to be mounting the 103 resistors There are 9 of them. Wow. And it's every spot marked 103 on the board. So that's no slouch, because that's a lot. So just quickly to count off the 103s for you guys. We have 1 right here, 2 here, 3, 4, 5, 6, 7, 8. I feel like I missed one. He said 9. Not on the other side. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8. I'm only counting 8, buddy. Where's your 9? 1, 2, 4, 5, 6, 7, 8, 9. Alright, I need to steal this for a moment. He's got 9. Oh, the board has changed. They got rid of 1. Alright, so there's only 8. Boy, is that a little confusing. Alright, so there used to be an extra one right here. There is not. So, and the 103s we are mounting are the ones that came in this big long strip. Three, 4, 5, 6, 7, 8. I am going to loose all 8 at once. Probably not a great idea, but kind of felt like fun. All right, let's go ahead and solder a little bit onto each pad to help us as we decide to get in here. All right. Oh, yeah. So we're gonna just grab some of the 103s and get in here with them. Ooh. All right, we're getting pretty close on all of these. So it's just one at a time. You go through. Thankfully, these do kind of wick into place once you get them at the right temperature. And then you just gotta gently hold them. Hard part, getting them upright. Alright, we got 2 left. I'm gonna try and mount these last 2 left to right just to make them look pretty, but as I've learned, orientation really isn't all that important on these. Come on, one more. All right, now that we've got all of them down, we're going to come back in for our usual stuff and quickly tack all these beautiful little boards down. I got a little glob I don't like here. I'd like to take it away slowly. All right, those are our 103 resistors now in place. So next thing, we mount the MOSFET. So the MOSFET, in case you were wondering, is the big guy. It's this guy, 3 pins. So big pad, 2 small pads here. Per the way we like to do this stuff, we start with the big pad. It's always the easiest to get in place. No, easiest is kind of relative. It's also kind of the hardest to get in place. So we're going to crank the temp up a bit. Sorry about bumping that, guys. This new stand's not working as great as I'd hoped it would. Hopefully this video will kind of be the exception on weird stuff you guys see from me. Hoping video quality has been going up over the last few videos. All right, so then we're going to quickly tack down that pad, and that pad, and then I'm going to come in and try and clean up this pad since it went a little rough. Oh, goodness, I picked up a bunch of those parts. Alright, that's not great, but I think it's about as good as it's gonna get. Alright. Alright guys, so the next thing we're going to be mounting is the 472 resistor. So the 472 resistor mounts just below our brown capacitor. So, if we get this guy out of its packaging, he goes right here. And he is this teeny tiny little resistor with a 472 on him. So we'll go ahead and solder a pad up Oh, and that needs cleaned. Very badly. There we go. All right, there's our 472 resistor mounted. All right, that is all of our bottom mounted pieces. Next, we move up to the top and the glorious Wi-Fi module. So we're gonna go ahead and tape this kind of down. So what we're actually about to do is kind of interesting. So I need to actually prop this board up so there's an 1/8 inch gap between the bottom of the board and my work surface. And then I'm going to be using these resistor wires to make a lead connection between each of these holes and the pin holes on this Wi-Fi module. Whew, this is going to get interesting. All right, so initially I just need to get it up off the ground about 1/8 of an inch. I think my best bet for that is probably to fold some tape. See how close I can get it to 1/8 of an inch. All right, so all I did was this. I just rolled some tape. It's not like precise, but it ought to work. So now I'm going to clip a set of the leads off of one of these guys. So we're actually gonna stick this through here and solder it on. Let's make sure this is all in view. It is. All right. So we're actually gonna come in here and I'm gonna solder that lead on there. And now I'm gonna cut it off and do this on all 4 holes. Well, the 4 corner holes anyway. Alrighty. Might be a little more than 1/8 of an inch on one side here. Alrighty. And we're clipping it each time. Alright, that looks like that's the farthest I'm getting with that one. Alright, now we're supposed to flip this guy over and use those 4 pinholes, or those 4 pins on here, and align them with the 4 holes on the Wi-Fi module. And then the Wi-Fi module will want to drop on. They're not perfectly aligned, so there's gonna be a little bit of work to do to get everything to line up, because they're not exactly straight. So I'm gonna come in real quick, and I'm using my pair of tweezers here to try and stand them as upright as I can to make their desire to go in these itty bitty little holes greater. It looks like I'm still off a bit. Sorry about that, guys. All right, that's 3. Why am I not getting 4? Ah, there's 4. Oh no, come on. Come on, little guy, come on. Come on, do not do this to me. Alrighty. Okay, I got all 4 on there. Now, let me double check. All right, so now we're gonna solder these pads, or these wires to these pads. We need to make sure we don't get any solder onto this big metal guy up here that's got all the text all over it. All right, that's one corner. All right, now we got all of those pads soldered. So there are 16 pads per side. As you can see, none of them make contact with the case. There are 6 pads down here on bottom that we will do absolutely nothing with. So we have all 16 pads soldered on all sides. So the next thing we're going to do is we're going to mount a 0.1 microfarad capacitor. It's this little brown guy here that I've got on screen, and he will go right up here. So we're real quick going to solder our pad. I need to clean my tip. All right, we'll grab our capacitor. All right. That's one side, and we'll pop in and solder the other side. I got a little much solder on the first side, so we'll come back in and reflow it and make it look nicer. And that is that capacitor on there. The next thing we want to do is we actually want to mount the 102 resistor on I'll flip it over for you guys, on the left hand side. So it's this one right here. We'll mount the 102 resistor, and I'm gonna mount it such that it's legible in words for you guys. Alrighty. So I got the 102 right here, and clean my tip again because it's getting a little dull. We'll come in here, get the pad melted, gentle amount of heat, and it is now connected to, there we go. A little crooked, but not the end of the world. It's still attached to the pad. Just like that, it's attached to the other pad. We're gonna come in and clean that up one more time. All right, the next one we're gonna mount is the 223 resistor. It goes right next door. And again, I'm going to solder this pad up right nice. Bring this guy in. Ooh. There we go. All right, make sure you guys can see that nice and well. We'll get it attached to the other pad. And that is our 223 resistor. So we've now got both those mounted right there. And we will move on. Next thing we'll be doing is mounting our red and amber LEDs. Remember, on your LEDs, the long pin, so there's 2 pins here, you can see one's longer than the other. The long lines up with the plus, so. And my red LED is the one we're starting with, and it comes over here. So the long one lines up with the positive, push it on through, flip her over, and then I just spread the pins and it's held on there. So now you can come in and solder it on. I don't actually care how square my LED ends up being. I know some people, that's like the end of the world, and there are several ways to jig it up, but it's just an LED to me. So I just come in and solder it on real quick. And then we come in and clip the leads. And we will do the same thing with our amber LED that is a clear LED. So again, long pin goes in our positive hole. Slide it on through. Grab our two leads. Spread them apart to lock the LED in place. And we will come in and solder the two pads. And then once they're soldered, we give them a little snip. And make sure you collect those pins. Keep track of them. Don't want to step on them. All right, and we have two LEDs. Next, we will mount our 3-pin header. So this is actually our last item, and it mounts right on top here. This one's actually tight enough to hold in. The other way to do this, if you don't have it tight enough to hold it in, is take a piece of tape, like gently wrap around the side here, and just kind of pinch it between some tape. So you just kind of make a little tent out of the pins on the upper side, and then you can flip it over and solder the 3 pins. I don't know how easy that was to see, but we'll just come in from the bottom now and solder the 3 pins on. Yeah, there we go. And then your tape just comes right on off, and you have a 3-pin header there. Now, optional are to put screw terminal switches on our outputs and our power. I did not do that, but they're pretty easy to put on. All right, guys, so on here, the board's now completely finished. So the next thing to do is actually to hook this up and use it. We have an in and an out. So this is where your positive and negative battery terminals connect, and this is where the output connects. These 2 channels are for continuity checking, so you can actually do a continuity check on your igniters in your rocket. So without having to turn the altimeter on, you can turn this guy on by connecting it to your battery, connecting your igniter, the switched side of your igniter, which is so weird, to one terminal, and the other side to the non-switch side of your battery. So like if your battery, or if your altimeter switches the positive line on and off, then you want the positive line connected here, the negative line connected there. This one comes straight from your battery. This one comes from your igniter, and it needs to be on the switched side of the igniter, which is kind of hard to tell. Some will just tell you. All of the EggTimer stuff will tell you which side they switch. They believe they almost exclusively switch the positive side on and off. But you have the ability to check both channels of your 2 igniters for your main and drogue on your rocket. If you're not using this in a rocket case, then you don't really need these channels. Or if you don't really feel like using these channels, you don't need to use these channels. If you plan to use these channels, I highly recommend you go read the documentation by EggTimer and look through exactly how they set these up. These aren't an area I feel like I need to use at the moment. I may use them for quick test leads onto my altimeter before I pack it up, just to do a quick continuity check without having to turn the altimeter on. but for the most part, I have my own test procedure for doing continuity checks. But otherwise, this just works as a simple switch in and out. So you'll actually have to connect this to a PC with a data cable. So most of us, if you've bought this, already have a data cable. Connects to these 3 pins and plugs into your PC. Then you can get out some lines of stuff that it'll be transmitting once you power it on, and that's how you'll get your data. I can read real quick directly from their thing. To get the pass key for your unit, connect a USB serial cable, the same cable that's used on all EggTimer rocketry products, to the 3-pin header as follows. Black wire goes to ground, white to TX, green is not used. Using an ASCII terminal program such as TerraTerm or HyperTerminal, connect to the serial port 115 with 200 baud, 8 bits, and no parity, and 1 stop bit. Now connect the battery to your Wi-Fi switch. You should see the following information pop up on there. There should be a few lines of what they call garbage as part of the boot process. It will then say Wi-Fi switch V1.02 or something like that. Then it will say SSID and show you the Wi-Fi name, and then it'll say passkey and show you the passkey for it. Passkey will be 8 digits separated by a space, and you'll need to write that down so that you can find it on your phone's Wi-Fi connection to connect to the altimeter. We will jump to a brief demo on how the interface looks, and maybe a brief demo on finding the information. All right, we're inside HyperTerm right now. We have got a spot where we are setting up the baud rate, which should be 15200, 8 bits, no parity, 1 stop. All right, so we've got that all configured. Now we can connect our camera. So I've added a quick battery terminal here just to a 9-volt. We are connecting black to the ground terminal, which is that guy, and white to the TX, which is on the opposing side, and green goes to nothing. Oh, sorry. So it connects like that real quick. Then we grab a 9-volt and we connect. So instantly we've got power on, and I'll go ahead and show you this because I don't really care. We get some garbage up top, and quickly get the EggTimer Wi-Fi switch version, our switch name, and our password, which I'll need to go ahead and write all that information down. So now we'll quickly jump inside the app on our phone and take a look at how this all shows up. All right, so when we come in on the phone, we got my internet. You can see there the Wi-Fi switch 1 C16E, that's it. Next, we enter in the password. The password gets entered in with no spaces, even though it shows a space in the key itself. Let's see if we can connect to that. All right, we're connected. We're now going to go into our internet real quick, and we are typing in according to the instructions. When we go to connect, we go to 192.168.4.1. So I will go to 192.168.41, which is just kind of all EggTimer stuff. Get rid of the message bubble that popped up. All right, a step I forgot is that you also need to usually turn off the data connection to your phone. I don't know why it affects it, but it often will not let a Wi-Fi browser load because it's trying to pull from the internet rather than pull from the Wi-Fi, because it knows the Wi-Fi doesn't have signal, at least on my phone. So when you get your page, it should look something like this. Output's off, toggle input, and then your channel A, channel B status. This will be your continuity checker if you're going to use continuity. We can also see that my 9-volt battery has 8.9 volts. Now, if I want to toggle the output on, I simply type the validation code there, which the validation code is 6823, and I hit submit, and now it toggles the output to on. Now, you'll also notice at the same time, it has turned on this LED light to let me know that that output is live. I do not have it connected to anything, but to turn it on, all I have to do is enter in a code again, which is 7422. The code changes every time you put it in. And so now it's off, and as we can see, the LED light is now off. So that's everything for the EggTimer Wi-Fi switch when you're wanting to use it. If you have any questions, please consult the user manuals on EggTimer's website. Also reach out to Chris. He's a great guy to work with. He has tons of knowledge on how these things work. If you're having issues, especially with your continuity, I really recommend you follow his instructions, and if you can't get it to work, reach out and try it there. I'll have to give it a try here sometime soon, and I'll probably make a standalone video on the continuity itself. But thanks for watching. I'll see you all in the next video.